Well, hello folks. I promised you a look at the panel box when I was bringing the wires in. As you can see, the yellow and the red wires have come down all the way down through from the third floor bathroom. Of course, the red one is the 10-2, the yellow one is the 12-2, and I'm going to bring them into the panel box. Now, this is a typical panel box. It's a Square D brand, and this is actually my sub feed. What do I mean by that? Well, coming into the house, I have a 200 amp service entrance, which means that's the load that the whole house can take. But since my kitchen and laundry room are on the far end of the house, which is where the bulk of your electric usage is, I decided that instead of running those heavy cables the whole length of the house to get to the main panel box, instead it made more sense to get one heavier cable, run it to here, put a second box in. This is a 100 amp sub feed, so there's a 100 amp breaker in the main panel box. There's wire, service entrance wire, thick enough to handle 100 amps that comes into here, and then from here I'm controlling washer, dryer, hot water heater, well pump, electric stove, dishwasher, microwave, and kitchen circuits, and the lighting circuits. So a lot of my heavier load is right here, so instead of having to run all those wires that whole distance, I just ran them right to here. That saved me some time and aggravation and some money in the long run. So then it's much more convenient if I'm working here or need to do something with the dishwasher or change out the washer or fix the washer. I don't have to run to the other end of the house, turn the power off. Now let me just give you a basic understanding of what a panel box is. This is bringing electricity in, and this is the same. This sub feed works the same way as a regular panel box does. If I had a house that had say a smaller house or didn't have a need for electric heat, I might have gotten by with just a 100 amp service as opposed to a 200. So this would suffice to do a smaller home by itself. As I said, what I did is I brought in this piece of white PVC. The main wire comes in. That's actually not the right color for electric work. Plastic PVC conduit is gray, but I only needed a small piece, and I had a small piece of this this 2-inch plumbing drain pipe. Since it's made out of the same material, has the same insulative qualities, and nobody's going to mistake that this is part of the plumbing up here. So rather than having to go buy a 5 or 10 foot piece of PVC conduit, I just made do with this. So, and what you see here, this wire here and this wire here are the two main hot wires coming in. Each of them is carrying 120 volts or 110 volts, whatever. And then your third wire is this twisted braided aluminum here. That's your ground. Now what happens is they come into the main bus bar here on the panel box. Here is a 100 amp disconnect switch right here. And that's what I'm going to do first before I go to wire anything. I'll turn that off. Then I know that anything from here up is electrified, but anything from here down is off. If you look in here, I won't touch it, but just to show you, in here where those two screws are, you see silver metal. These are the two legs of the panel box, and that's where the electricity travels down through. If you look down here on the bottom, you can see that they end down here. And what happens is, if I were to take all these breakers out, you could see that as they travel down, they've got teeth, alternating teeth back and forth. Each one of these two legs carries 120 volts, as I said, but to make 220 for your heavier things, you get what they call a double breaker, double pole breaker, like this double pole 30 or this double pole 50. I think this is for the dryer and that's for the electric stove. And what happens is it touches both one side and the other. A single pole breaker, for example, like this one right here is a single pole. That only touches the one side, so you only get 120. What I'm going to do is I'm going to put a single pole 20 for the electricity, main electricity for the bathroom, and a double pole 30 for the future hot water heater that's going up there. And I just have enough space left on here. You can see on this side I can get 2 in, and on the bottom here I can get 1. But that's going to do me. That'll fill out this panel box. Another couple things that you can see here. This breaker looks a little different. That's a GFI breaker. It's a 20 amp circuit. I believe that's for one of the kitchen runs right here, right beyond this wall. Again, anything within 12 feet of a water source, you have to have the break receptacles protected with GFI. So rather than fool around with the several GFI receptacles or doing the downstream thing like I explained in another video, I just put a breaker in, and if it goes bad, then I can just change the breaker out. If you look here on either side, you see this silver bar with these screws, and those are your grounding and neutral screws. That's where your white wire and your bare wires go when you're connecting up. Your hot wires are going to be the ones that actually go into your breakers, and I'll show you that in a second. The other thing that I like to do is I will leave a little bit of a piece of the outer insulation jacket on in here, and I'll mark it. That way I can tell really quickly which wire is running to which circuit. Let's see, for example, this one's marked DW. That means that's for the dishwasher, and so on. Now, on the panel box cover, I've already taken the cover off. It's held in place with about 6 screws. If you look down here on the cover, maybe I can get down in here a little bit for you. You can see that I have the spaces marked so that I know which circuit controls which. On the panel box itself, the cover comes closed, and each of these are spaces that I have broken out. These little metal pieces here will bend out, and you only remove them. They're like knockouts in the junction box I showed you. You only remove them when you're going to put a breaker in. That way, if somebody opens a panel box door, they can't stick their fingers in and touch the places where they could get a shock, either on the screws of the back screws here of the breakers, or in the actual bus itself, the actual legs themselves. So that's why you break these out as you're putting circuits into your box and not before. Now, as I said, I'm going to be putting in, let's start first with the simpler one. This is a, let me see if I can do this, there we go. This is a 20 amp, you can see the 20 on it, 20 amp single pole breaker. Now the screw is here in the back, you can see there. You open that and you strip your wire about maybe a ½ inch or so, stick the bare wire underneath the screw and the mounting clamp there, and you tighten it down. This is going to be taking the power to whatever circuit you're putting it on. That particular wire is the one that's going to be electrified. What the breaker does is it passes, the electricity passes through it and then down the line to the circuit. If there's a problem in the circuit, the breaker is designed that if there's a short, it will trip out. That's what this switch is for. Now, in the old days, they had those plug type fuses which broke if that happened, and then you had to replace them. Here it's just a question of flicking the switch to reset them after you fix the problem. On the underside, you can see in the front of the breaker, you can see this grip, metal grip. That's what grabs a hold of those blades, the blade there on the panel box to the that's electrified. That brings the power into here. On the back, in this particular design by Square D, it has these little feet that hook on, if you look right here, they hook on to the plastic on the outside to hold them in place. You're going to snap them in so they're good and tight. These don't move really. I mean, you don't have to worry about them falling out because they're in place very well. So that's what I'll do with the electricity for the bathroom. It'll all go on to this 120 amp breaker. That'll be the receptacles, the light fan combination, the vanity light will all be on that. And then for the future hot water heater, I have a double pole. You can see it's twice as thick, 30 amp breaker. This is for 220 volt circuit, of course. And again, if you look here on the bottom, you can see it's got not one clamp but two, because as I said, it clips to the ears on both sides, on both lines of the bus bar, so that you pick up 220 volts. And again, it's got the feet on the back to snap it in place. Works the same way. Basically, you turn it on. If there's a short, it kicks off, and then you can reset it. So each breaker is labeled with its amp capacity on it. You don't want to put a heavier amp capacity breaker in for the wiring you have. This 30 amp will work with the 10.2. If I used a double pole 20 with the 10.2, then that wouldn't be heavy enough. Double pole 20 will work, as I said, for electric heat, but it won't work for a hot water heater. So that, and this double pole 20 here, I think, is for the well pump, so that works as well. But basically, as long as you're careful and you use some common sense safety, you can work around a panel box here without fear of frying yourself. The important thing is always make sure that that main disconnect switch is turned off. Now, I wouldn't trust my life on that, of course, but I know that if I turn that off, there's less likelihood that there could possibly be any power going through. You just want to be careful of that. If I was really concerned and had a lot of work to do in here, what I would actually do is I'd go over to my 200 amp box, the main service box coming into the house. I'd turn that 100 amp breaker right off that's bringing power to this box, and then none of this would be alive. It would all be dead if it was working properly. And then I'd turn this one off too, so I'd have a double layer of safety to work. But I don't think that's necessary. I just need to put a couple in down here at the bottom. So I will turn this main 100 amp disconnect switch off, and then I should be fine. I'll know that it works because as soon as I turn it off, I'll lose the lights in this room because they're on this circuitry. So that's going to be my plan to do that, and then basically I should have power up in the bathroom, and then also I'm all ready to go when I do decide to put the hot water heater in. All I have to do is make the electrical connection up there and turn the breaker on here, and we'll have hot water there. So I hope this has been helpful for you as far as demythologizing electricity and what you have in your home. Like I said, just be very careful that your power is off, and don't do anything stupid. You don't want to be standing in a puddle of water while you're working here. You don't want to, you know, stick your metal screwdriver tip against the live blades there or anything like that, because that's when accidents happen. But if you're careful and use common sense, this can be done by the average homeowner. You can change out your breakers. If you get a breaker that starts going bad on you, that it's tripping out for no reason, no apparent reason, you can change it. If you have to replace one with a different one, say you have a different circuit, a heavier circuit, a lighter circuit, whatever, and you want the breaker to match it better, that's not too difficult to do. Again, you just have to be careful how you do it. Now, if I'm going to pull, say I'm going to pull a breaker out of here, what I'll do is I'll take my screwdriver tip here in between and pry it that way, because that'll pull the hot clamp off first, and then I can rotate the feet out and it'll be free away from what's electrified. But again, it's still better to turn the power off before you do any of that. And then when you put it in, you do it the opposite way. You hook the rear feet first and then push until it's good and solid. And you can tell when they're all lined up evenly. And also, that's the other reason why in the panel box here you've got this center partition. If your breakers aren't in all the way, that won't let you. That should fit tight. That the breakers come flush with this. You know, that it surrounds them. If it's not doing that, then your breakers aren't in properly. So that's just another built-in safety feature for you. That's about all that I can tell you about this. If this were a main panel box, you'd also have a heavy duty from your grounding screw here, you'd have a heavy duty copper wire, which is your main house ground. If you're out in the country, that means it runs to a stake in the ground, an 8-foot stake. If you're on a city water line, it means it runs to the pipe coming into the house from the water line, assuming that it's metal, so that it's grounded that way. So, but since I'm already grounded on my main panel box, the ground is carrying through here to this braided wire, so I didn't need to double that by adding another ground stake outside for this, since this is just a subfeed. Okay, so we'll give you the good news in another video after everything's working electrically, and thank you for watching. Please don't forget to subscribe to our channel.